Hi everyone, I'm Youssef, CTO of Graphic, and I'm truly happy to be here with you today. Graphic is a French small startup specialized in LabVIEW and deep learning, and today we are proud to introduce the first AI frameworks powered by LabVIEW and built entirely around ONNX and ONNX Runtime. Now, I know that most of you probably aren't yet familiar with what ONNX or ONNX Runtime actually are. So that's why in this presentation, I will take a moment to explain these technologies, the challenges they address, and why SOTA, or AI ecosystem, matters not just for the world of artificial intelligence, but also as a potential game changer for the NI community. But today, I will not just present another LabVIEW toolkit to run a few models here and there. No. What we are presenting today is a full-fledged solution, one that can stand shoulder to shoulder with the current AI giants like TensorFlow, PyTorch, or Keras. Today, we are opening a new chapter for what's possible with LabVIEW and presenting a serious contender to the solution backed by Google and Meta. We have 45 minutes together, and I'd like to leave at least 10 minutes at the end of for your question. So without further ado, let's dive in. And let's start with something essential to understand when we talk about AI, the current AI landscape. Okay, what I'm showing you is something everyone needs to understand before building AI solutions. It's the standard workflow of today's AI ecosystem. We start by designing and training models using leading AI frameworks, Keras, TensorFlow, or PyTorch. All is in Python. These frameworks are great for prototyping, but deployment often becomes painful. To run models efficiently on various devices, we often need to convert them into ONNX, a universal open source system file format that enables models portability across diverse platforms and frameworks. ONNX was initially created by Meta and Microsoft and is now maintained by the Linux Foundation. So once the model is trained, we export it to ONNX. From there, the ONNX ecosystem takes over, and we can deploy the model to a wide range of execution environments: GPU, CPU, NPU, and now and also FPGA. Using highly optimized execution providers maintained by major hardware vendors like NVIDIA, Intel, AMD, or Qualcomm. On paper and in practice, this is already a major achievement. This workflow is solid. It's the path most have taken. But let's talk about ONNX system file. This ONNX-based workflow is solid. It's the standard path most teams have adopted when aiming for model portability and deployment at scale. ONNX provides de facto interoperability. You can go from or to ONNX from all leading AI frameworks, and that's already a significant level of flexibility. In theory, this universal format allows teams to switch frameworks relatively easily. A project start in PyTorch can be continued in TensorFlow or even in Keras, and vice versa, with a minimal rework. This opens the door to long-term maintainability, modular collaboration between teams, and greater freedom in selecting the most appropriate tool for each stage of AI lifecycle. And now, let's talk about ONNX Runtime engine. In the meantime, ONNX Runtime plays the role of high-performance flexible engine for deploying AI models across a wide range of platforms. It ensures optimal execution by leveraging execution providers, hardware-specific backends such as NVIDIA CUDA, NVIDIA TensorRT, Intel OpenVINO, AMD ROCm, AMD VTSI, just to name a few of the most well-known. What makes ONNX Runtime unique is that these backends are not third-party hacks. They are developed and maintained directly by engineers from Microsoft, Intel, AMD, Qualcomm, NVIDIA, and other hardware leaders. This guarantees the best possibility hardware level optimization, meaning that whether you are deploying on server, an edge device, or embedded hardware, you get the most out of your silicon. And this is ultimate flexibility on industrial grade optimization that make ONNX Runtime the ideal choice for scalable and efficient AI deployment. Now we know what is ONNX and ONNX Runtime. Let's go back to LabVIEW. So, in parallel at Graphic, we've been working on deep learning with LabVIEW for over 5 years now. Our first generation toolkit, called AIBAL, was a native deep learning toolkit fully developed in LabVIEW with no Python dependency. At the time, our ambition was already clear: bring machine learning directly into the LabVIEW environment, fully integrated. But today, we refer to it as a legacy generation for two main reasons. First, AIBAL was based on the HDF5 file format, which turned out to be too limited for accurately defining complex model architectures. Second, the LabVIEW runtime itself isn't optimized for executing deep learning workloads, even on CPU. And we'll come back on this later with some performance benchmark I will show you after to make a comparison, to better understand how it works. So what you're seeing here is a video demo of AIBAL recorded back in February 2023, and it marks our first step toward what would become SOTA. But at that time, we were clearly not at the level of the state of art, and more generally of the main AI frameworks. Look at this framework. It's already solid and represents today the path most have taken. We knew it, and what we truly wanted, and what naturally guided our roadmap, was to build a toolkit that is fully up to date with modern AI standards. A toolkit that allows you to import, edit, create deep learning models from or to any of the leading AI frameworks. And above all, a toolkit where execution is as efficient and optimized as possible regardless of the hardware. All of that without relying on Python, without Jupyter, without Docker, just pure native LabVIEW. So now let's be a little provocative. For people who doesn't know us, it's a kind of our trademark. Let's speak about LabVIEW. We all know it. Yes, LabVIEW is the only true Dataflow programming language. Yes, LabVIEW has been the ultimate platform of test and automation. But we forgot something essential. We've been thinking about this a lot, and here is the real question we ask ourselves. LabVIEW is amazing. We all agree. Everyone say LabVIEW is powerful. So, where do I train my models? Where do I build neural networks visually and natively? And more importantly, where is the compatibility with other AI frameworks? Where is the full palette of features to match what TensorFlow or PyTorch offer? Where is the ability to run cutting-edge models efficiently and not like a joke? We looked for it, we didn't find it, so we built it. And this is where SOTA comes in. Let me introduce SOTA. SOTA is the first deep learning framework built entirely on ONNX and ONNX Runtime. At the core of SOTA is a complete and flexible orchestration engine designed to manipulate ONNX graph natively at every stage of the workflow. So deep learning become not only powerful, but also modular, intuitive, and full accessible to LabVIEW engineers. For the first time, we have a powerful AI tool designed in LabVIEW and more. Unlike standard ONNX Runtime engine, which allow inference and limited training, our technology enables the full orchestration and customizable of training graphs. So SOTA is not just about inference. It also supports training, including supervised learning, reinforcement learning, and even more custom architectures. To review, we can do what we want. So we go further on how we did it. Because Graphic is not just a user of ONNX Runtime, we are also a contributor of ONNX Runtime project. We are the only European company among key players like Microsoft, Nvidia, Intel, to name a few among others, to work on this project. So we work directly with these key players and actively maintain the training logic inside the runtime. That's what gives us a unique position. We don't just use the ONNX ecosystem, we help shape it. And SOTA is the first framework to full expose and orchestrate that power visually in LabVIEW. To give you a landscape before a demo, so we will start now a demo, but before I would like to show you a latest a slide. SOTA is like Microsoft Office, but for artificial intelligence. SOTA is a unified suite of easy-to-use, interoperable tools, each more innovative than the last, designed for engineers, researchers, and academics. Fully visual, fully interoperable, and natively integrated into LabVIEW. SOTA is made for customs who want powerful AI capabilities without the complexity of fragmented ecosystem. Each toolkit solves a major bottleneck in the modern AI pipeline, from deep learning and computer vision to generative AI annotation and model importation, and even natural language processing with LLMs. But SOTA goes further. We also developed our own distribution system with one-click installation, license management, and seamless update delivering. Everything is managed through SOTA. And again, before the demo, what makes SOTA truly unique? It's the only AI framework natively built on ONNX. There is no framework like this. There is no existing framework in the world built on ONNX. It's the only AI framework full powered by ONNX Runtime, not just used, but extended. And there is no framework using natively ONNX Runtime in the world. So we are the first. And this is the first even deep learning environment entirely built in LabVIEW. So we decided to use LabVIEW as LabVIEW is for us the powerful tool. So now, time to the demo. Okay, now let me show you what SOTA can do. First, we orchestrate any graph using LabVIEW diagram. We can visually define the structure of any ONNX model. So as you can see, it's not so hard. Then with the second orchestration, we control the execution of the model through ONNX Runtime. This dual layer orchestration makes it possible to design and run any execution architecture, all without writing a single line of code. On the domain like computer vision, generative AI, reinforcement learning, or more broadly, every field in artificial intelligence benefit from its comprehensive capabilities. Here, for example, we saw a YOLO model for computer vision, and now we see a UNet model for biomedical. So this is a segmentation model. So from a frozen snapshot model format, we made it a dynamic graph technology fully orchestrated with LabVIEW. And now we can also do, for example, reinforcement learning, showing reinforcement learning, showing you that we are able to do what we want, because reinforcement learning is a pure example of any architectures. So we integrate all graph directly in QMH, Q message handler, actor framework, or state machines. And it works, and it's magic. So LabVIEW brings accessibility to deep learning field. And that's magic. So so this is the famous Formula G. So some people here already know, and we make a reinforcement learning directly on it. It was shown during the NI Connect at Fort Worth. Okay, we also do generative AI. So it's possible, for example, to run any LLM, VLM, SLM. So large language model, visual language model, or small language model. And what you are seeing here is DeepSeek R1, who is running with no problem locally on LabVIEW. So it's possible directly in architecture, in any architecture, LabVIEW architecture, industry or research or academic, you can integrate directly any agent if you need, for example, to format some data and analyze some data and directly use it in some clusters. From JSON to clusters, it's possible to do it. Okay. Now I want to speak another things before the live demo. is we do more with SOTA, because SOTA is more than a sample suite. Developing AI depends on a patchwork of tools like TensorFlow, CoreML, LlamaCpp, to name few. All these tools excel in their domain, but none provide an end-to-end solution. As a result of this situation, of this fragmentation, teams must juggle multiple tools, leading to delays, rising cost, and mounting complexity. On AI workflow is also different steps: data preparation, train, hardware optimization, integration. Each step requires switching tools, introducing delays, compatibility issues, and spending cost. And this fragmentation is in all AI field. What you see in the background is the MAD landscape. It named MAD. This is the true name. A giant map of tools of machine learning, artificial intelligence, and data, MAD. And why we call it MAD? Because the landscape is huge. It's the reality we are all faced when we're starting an AI project. Which frameworks? Which infrastructures? Which tool for each steps? This extreme fragmentation creates hesitation, complexity, and overhead. It slows down innovation, increases implementation risk, and raises costs. And that's exactly where SOTA comes in. SOTA is not just another tool in that landscape. It's the alternative to it. A unified, complete, and native suite for AI development, designed to eliminate fragmentation and make AI implementation efficient again. And all in LabVIEW. For the first time, we have at our disposal a game changer on the latest technology of the moment, AI. In review, SOTA also addresses the fragmentation and complexity of modern AI workflow. So, logically, SOTA covers major AI competitors. Okay, before doing a live demonstration, a little preview of the future of this project, which I think will interest you, and yet. What if we could go even further? Because building and training models is only one part of the story. Let's step back and ask deeper question. If ONNX is a universal graph format, where is the universal graph editor? Why should editing stop at neural network? Why not edit and orchestrate any computational graph? And if ONNX Runtime is the ultimate engine for efficient execution, why not make ONNX the foundation for any intelligent, modular, inspectable, and executable system? That's the vision we are building with SOTA. And because ONNX Runtime is today most efficient execution engine, and because Graphic is the only actor in the world providing a true native ONNX editor, not conversion, not export, but fully native edition, orchestration and execution on all in LabVIEW, so you can import, edit, create, modify, you can do what you want in graph technology with ONNX. And we are the only tool doing this. Normally, if you work with AI leading framework, Keras, TensorFlow, or PyTorch, you need to convert. But in your technology, we are not in conversion. We are just native. So we can do what we want. So why should this limit it to AI? We looked for it. We didn't find it. So we built it. So let me generalize ONNX. Let me introducing for you the generalization of graph technology. So what we did, we made it a foundation for graph computing itself inside LabVIEW. And now, before the live demo, let me show you what we unlock. Okay, so the functionality is the same. So I need to launch the video, sorry. Voilà, sorry. So let's see the orchestration. So we did an accelerator toolkit, is a generalization for all operation graph, because the idea is if we are able to do artificial intelligence, which are complex calculation, why we don't generalize for all operation? And that's exactly what we did. We do first an orchestration of ONNX, so we are able to define any functionalities, and then we execute it. So what kind of field we are make application? So we can do a test and measurement, why not? Just a graph. Or computer vision, also, we can do it. It's just a question of all functionality, we graph it. And all functionality are optimized on any hardware. That means LabVIEW everywhere. Because ONNX Runtime engine could be deployed on any hardware. So LabVIEW everywhere is now possible because we can compile directly our functionalities on any hardware system. And what you can see here is some benchmark. So let me give you some detail of benchmark. For example, here we have a computer vision. The reference is OpenCV. We are faster with our ONNX Runtime engine. And we are the only company in the world. It's not totally true because Microsoft also working on ONNX Runtime, and a lot of functionalities like Paint, for example, are done with graph technology because they voluntarily optimized Windows with ONNX Runtime. So when you use, for example, Windows, you have a lot of functionalities developed with ONNX Runtime. So we are not the only company. Microsoft also do it, but we do it. So we do computer vision, and as you can see, we are speeder than OpenCV, the worldwide reference. So that's a good news. Okay. Another thing I want to show you is we also benchmark a matrix multiplication depending on its size, and make a comparison between LabVIEW CPU native and what we are doing. So we have the multiplication, LabVIEW native matrix multiplication, and also LabVIEW gem multiplication. So you have different benchmark. So the results speak for themselves. The more memory you need, the more speed ratio increase in our favor, up to 5 times faster. And we stop the test because we can continue. So now I finish my first presentation. I will make you a live presentation. So how long time? We have, what time is it? Just give me 1 second. Okay, I will take 10 minutes, about 10 minutes to make some presentation, and then we will be able to exchange together. So let me introduce you. So let me just share. Okay, let me share my screen. Okay, so let me present you SOTA. So SOTA now is available. You can download it directly on the Graphic website. So it's available. It's free for students, of course, and you can easily download any library, accelerator, computer vision, CUDA execution, deep learning, generative AI. CUDA execution is the old school to execute CUDA. So now it's free and it will be open source. We will open source it in few days. Add-on. Why we did our system and we didn't use VI package manager? It's because we have our toolkits, but also we have add-ons like tools. In our tools, we have the file importators. It's a tools, so it was not possible to install it with the classic VI package manager. And also, for example, if you want to use Netron or other tools, it was not possible. But also, when you do artificial intelligence, you also need to download models. So different models, like when you go on Hugging Face, for example, the reference, you can download models, but we also propose some models directly integrated in your architecture of LabVIEW, directly operational in our example. So I will show you after. And also we have some environment. Environment, it's to do reinforcement learning. And also if you need to install hardware like CUDA driver, TensorRT, OpenVINO, all of this kind of driver for the deployment of LabVIEW. We propose directly an installation with SOTA, and also we manage. We have a system file, license system file. So okay, how it works when you installed? You have a palette, LabVIEW palette. Let's watch some examples and let's run it in live. I will show you the power of LabVIEW in live. Okay. Tac. So I go back to the chat. Okay, so this is our visualizer of examples because we prefer to do ourselves. So let me show you a computer vision example. Okay. Okay, this is a computer vision example. So you see my desk now. Just give me 1 second, please. Up, up, up. Okay, I appear again. Okay, so in live, you can make detection and you can make segmentation, and it works in live on everything. You see what? Maybe, I don't know, pen. You don't see the pen? Ouais, bon, il le voit. Okay, so what you see here is the power of LabVIEW, because you can directly act on the different model, on the model. And for you, it's natural. But for people who are using deep learning, this is a revolution. It's not possible to do this normally when you do computer vision in artificial intelligence. Because when you see demonstration, this is, let me show you the diagram. The diagram is very simple. It's just a while structure. But it's familiar for all of us. But for artificial intelligence, it's complicated. It's not, when you do Python, it's hard to do this. So what I'm showing you is a live demonstration showing the powerful of the tool. Let me show you another things, another example. So, up. Okay. Okay, I can show you, for example, the lunar lander, a reinforcement learning system. Okay. So this one is very particular because you have an agent and an environment. So you have to install an environment. What you see here is the environment from OpenAI. It's a Python environment, but we propose an installation without installing Python. We develop a technology to encapsulate everything with SOTA. So you just install directly OpenAI environment, and after that you can make your test. And in SOTA for academics, we propose different algorithms to explain how it works. So what you are seeing here is the lunar lander training. So it's training in live, and so this is an agent, and this is the environment. You can see in live. So now it's training. Normally it takes about 10 minutes, 15 minutes to train and to have something working efficiently. So yeah, and what is very good in LabVIEW is, I need to stop it to show you the diagram. Let me show you the diagram. Diagram is a simple QMH. It's not necessary to make complicated. It's a QMH, and we communicate asynchronously with the environment, and it works perfectly. So the marriage, the combo between ONNX Runtime, and LabVIEW is magic. And as we decided to work to be, as we are graphic, so graphic is graphic programming language LabVIEW, but also graphic graph technology ONNX. We are half. So my company is working on the LabVIEW and also ONNX and ONNX runtime system. So that's why we are an active contributors. And the combo of all of this give you this result. And we are totally compatible with all leading AI frameworks. Another example, if you want, let's go to the medical way. So let's run it. Okay, let's go. Okay, this one is a segmentation model. It will train to, so you have something you can do with LabVIEW is in live you can see the data set. So that's the data set. That's the features, and that's what we want to make prediction. And in live, we see directly the training working. And in live, and it's not possible to do this in making this orchestration. It's not possible to do it outside LabVIEW, because LabVIEW is a really powerful tool to do it. So what can I say? It's magic. It's magic. For the world of AI, it represents a big step forward, because it opens the possibility to do a lot of new things. We can monitoring in live all training, all models, and for implementing in industry or also in a research lab, it could be accelerate a lot of people. Okay, so it's training. Let normally it will go speed. Normally this part will be blue. So he is trying now to find the solution. Normally it's about 2 minutes. So let him working. And during his working, let me show you another example. What can I do, Florence 2? Okay, Florence 2 is a Microsoft model. It was a VLM model. Let me show you. When it was released, it was an important step for Hugging Face company because it make a boom of frequentation on Hugging Face. Hugging Face is a big company, a major actors. Bon, during dommage. Bon, is loading. Sorry. Because during his loading, he's finishing here. So the demo effect. Okay, so is maybe if you have some question, I can take the question during the loading if you want. If there is some question. Is ONNX ORT is free to use for anything? Yes, it's an open source project. ONNX Runtime is an open source project backed by Microsoft, essentially Microsoft. They give 48 engineers fully working on the ONNX Runtime. And also NVIDIA is working on it, Intel is working on it, AMD is working on it. One thing is very important to know about ONNX Runtime is, let me show you. Tac. Just give you, sorry, I'm not on the good. Voila. What is very important on ONNX Runtime is you can deploy models, deploy your graph on all of this material. And the list is not full because I don't have enough space. But you have to retain that it's NVIDIA, AMD, Qualcomm, Intel, all the material, also CPU, GPU, NPUs now, because now they speak about Silicon Valley speaking NPUs, and of course Xilinx FPGA. Okay, still loading. Okay, this is the demo effect. I'm sorry, this is the demo effect. Up. Okay. Do you have this example? Seems to be running in parallel. It works on any. Okay, Vija. It works on any. This examples means to work in parallels. What are the power requirement, hardware required for this? You can work for the training. It's only in CUDA because ONNX Runtime teams choose to focus on the leaders. So if you want to train models, the best way is to use NVIDIA GPU because now NVIDIA is the leader of the market for now. But for deployment, if you want to deploy models on hardware, you can deploy it on any hardwares. So if you have Intel GPU or AMD GPU, it will work on also CPU. Okay. How FPGA? FPGA, we have Xilinx VTIS AI, so we are compatible. ONNX Runtime is compatible with VTIS AI, and Graphic took the lead. We also, as we are participating to the ONNX Runtime project, we also took the lead for the testing of all the nodes because graph is different node is operation, so it's different operation. And we have to test all the nodes for all execution providers to know the compatibilities and to give a complete map for developers and also for industry. And about FPGA, we are compatible with Xilinx Runtime. So we are compatible in the paper. We are compatible with FPGA coming from Xilinx. Any question? Okay, let me continue with Florence. So now it's load. So another example I can run. Okay, car. So we create models. So we also developed in competition with Hugging Face. We developed our own transformers library. So there is a transformers library working in ONNX Gen AI. but we also ONNX Runtime. But as we work since 5 years, we also our own transformers library. What is a transformers library? Is, for example, detail caption. Okay. And so here caption is it gives you the description, a green card. Here Florence 2 is a model that you can prompt it with a list of prompt, and with this list of prompt it will give you an information. Is ancestor of VLM on ChatGPT. But it's powerful because for industry it was powerful. Now we use ChatGPT or Qwen, and we can run Qwen on ChatGPT on all this kind of models. So we can also do this with our technology. So let's go back to the test of medical, and as you can see, it trained. So the colors now are good. Okay, let me stop it. Okay. What can I show you? Maybe I can show you the diagram. So as you can see, diagram is always easy and simple. LabVIEW orchestration is powerful. LabVIEW orchestration, we think in the future, this is the future of AI. And we hope that NI will release LabVIEW community 64 bytes for students, as we are free for students to make a complete release, free release for students. So is there any other question? Okay. For now, we can train and we can create ONNX models directly because what is the model? Let me show you what's model. For example, Florence. When you want to see a model, we can visualize the model like this. This is ONNX system. Okay. So when you want to visualize model, you use Neutron when you are working on I field. For a LabVIEwer, this is something strange because LabVIEW has already a diagram, and the diagram of LabVIEW is powerful. So, but they use it. So to answer about Jetson Orin, what we can do now, we can train model, we can prepare the model, but you will have ONNX, and you can deploy directly ONNX without LabVIEW, because LabVIEW for now is not, there is no LabVIEW arm. So it's not possible to deploy LabVIEW. We can deploy models, but it's not possible to deploy LabVIEW. So maybe in the future, a version of LabVIEW ARM will be released. As soon as the LabVIEW ARM will be released, SOTA will be totally compatible with it, and it will be possible to develop and deploy directly your diagram LabVIEW on Jetson Orin. But we are depending on NI, on the development of LabVIEW, on the deployment of LabVIEW. Okay, what does SOTA stand for? SOTA means state of art. State of art means because we want deep learning toolkits, we want computer vision toolkit, we want something in state of art, because of course it exists toolkits on LabVIEW, but the problem of these toolkits, this is not state of art. State of art means you are compatible with the leading AI frameworks, Keras, TensorFlow, PyTorch. You are also compatible with leading system file, ONNX, and you are able to deploy on any hardware system. If you are not on this requirement, you are not state of art. Alors, insightful introduction. Okay, it's not a question. Okay. Okay. Is there any question about what you have to remember is now LabVIEW gives you the possibility to do deep learning. You can now run as you want any models. You can import, export. We have a universal system file, ONNX, and Graphic is working with the ONNX community. So it's not only a use of ONNX, it's because we also maintain it. You have now the possibility to deploy models on any hardware with ONNX Runtime. And what can I say also? We are the only one company in the world making training with ONNX Runtime, because ONNX Runtime initially was not done for this. It's just for efficient inference on any hardware. But if you are able to do inference, you are able also to do training, because inference is training is inference, but in the other sense. So that's why we decided to continue to develop it and to work on it and to make it possible. And we go far beyond, because normally ONNX Runtime is only do for inference, AI inference, but Graphic, we decided to do also to generalize all the operation of possible. So the full LabVIEW palette, for example, we release this week. Normally we release accelerators. You can download it, test it, and you will see that the difference between any other toolkit, I think we blow everyone. Can you show pulling someone else model? Can you show pulling someone else models from some other tools and running it in LabVIEW? Okay. Maybe Norm, you speak about. Okay, we develop also Fig. It's one of our tool. Fig, it's file importator and generator. It's a file importator of, for example, any models from leading AI frameworks. For example, if you are a team already working on the AI, and you're already working on the PyTorch, Keras, TensorFlow, we can import directly the model in LabVIEW, and you choose which you can directly run it in LabVIEW in your architecture, so it's natively take in charge, or you can also modify it. And this is a new things, because this is an ONNX model. ONNX model, you have to understand one thing. ONNX model is a frozen. It's a frozen snapshot of model. That means it's not possible to change it. It's finished. When you have this format file, it's finished. You do nothing more. And with SOTA, what we can do, you can import it and you can modify it, because we are the only editor of the world working on ONNX. It's important to not make the confusion between conversion from Keras, TensorFlow, PyTorch, and a complete edition model that we can import, edit, modify, create. We can do whatever we want. So let me show you. I will load the file. So let me load the model. I have my repo Fig. Okay, so here you have some model H5, PyTorch. H5 is for TensorFlow or Keras on ONNX. So as it's a demo, I will open a small model in order to open it, because I can open big, but it will take more time. So I open it. Okay. Here I can neutronize it. So neutronize it means this is the model, I open it. And as you can see, as easy it is. But so you have the first stage to see the model, but it's not enough. I want the resume. Choose what kind of resume you want. So I want a complete resume of this model. So you have all the nodes directly. This is the standard, and you have directly the number of parameters. So this one is 40,000, about 40,000 parameters. Okay. Input, output, what we do. Okay. And then I want to export it. I want it in LabVIEW. So with a complete up. And what we do, ladies and gentlemen, this is a magic. So what we are doing here, we are generating this in LabVIEW. So now he's working, so he's doing. So it's a small model, but as you can see, a small model can take a time. So if I take a big model, it will take more time. So we directly generate a frozen ONNX model, a static model to a dynamic model, and we combine LabVIEW with ONNX, and that's the magic. Because as soon as it will finish, you can add layers if you want. You can add nodes. You can add what you want. Another thing, if you speak Keras, you speak to the engineers. You speak layers. Layers is a combination of nodes. If you want to be more research and more down, You will speak TensorFlow on the PyTorch. You will speak nodes. With our abstraction, we speak layers on nodes. We do everything. SOTA is compatible with everyone, with every kind of teams. You are researchers, you can work with us, with this system. You are engineers, you prefer Keras. You also have the possibility to have exactly the same abstraction as Keras. We do all the level of abstraction to give you the access of the full AI. So thank you. So what you see here with a small resume. So this is that. But the difference is if I want to change variable, I can change it with no problem. If I want to add, for example, layers, easy. I can choose, so I can choose here. Let me show you. Oh, sorry. Architectures is ONNX world. Runtime is ONNX runtime. So architectures, we choose layers or node. We can get and set. Get and set mean different parameters. You want to change parameters of your models. We can in live change everything. And we have some graph function for resume, neutron, or everything. So layers or nodes. Okay. On nodes, and you have all the nodes, all the operation available. Everything is available. And it represents about not far 5 years of works, and it represents also about 4,000 or 5,000 VI. The project is huge. I think it's the most huge project exists in LabVIEW or in top 5. We developed more than 5,000 VI. So you can do what you want. So we can import, and we can also export. For example, let me export in ONNX. Let me show you. I take a layer. Okay. It's very simple. With dance. Okay. Let me give, for example, give you. So this is the shape, the dimension and shape of input. I can build any model like this. Sorry. Okay. So, okay. Okay, and if I want, for example, to see what I did, so I can have the summary. I connect directly the summary. Sorry. It's very simple. Summary. I can choose the complexity of summary. I will take complex. If I run it, I have my summary. So input to dense, very simple. And if I want, if I prefer, we have to. I had an idea to make it a neutron. So if I want directly to save it, so that's what we call a full editor. If you want to save it, for example, ONNX file, because this is our native system file. I'll save ONNX. Okay, let me save it. Okay, create constant. Okay. Create constant. Okay. Just give me 1 second. I will create here a folder test. Okay, and I will save it in test. So let me take the path. I think I'm not sure it will work. Let me change in control. Okay, okay, okay. I will not take it. Okay, just give me 1 second. I will voluntarily take this one. Okay, and I will edit it. Okay, so because I have example ONNX here, but I will delete it. So delete it. So I will voluntarily go to test, not to just to not cheat the demo. Okay. So we have nothing here, as you can see. So I run it. Okay. And now we have example here. Input, dance, dance. We can import, export, modify. We can do what we want. So that's the things. And the revolution is now it's available in LabVIEW, and we address LabVIEW community and also AI community. The idea is to bring the AI community to NI ecosystem, and also on in particular LabVIEW. So we can do what we want. So what you can see here is the ONNX system file. So this kind of features, we are the only one in the world doing it, because normally ONNX was not done for this. We change normally ONNX is a format for sharing, and you make conversion to go from or to leading AI frameworks. What we did a complete graph edition system. So if Jackai expert its model, yes. Yes, Norm, we can do it. We can run it. The thing is, I have a problem with my. I want to make a demo, but the problem I have a okay. I have a license problem for okay. Norm. Okay, I can make you a demo. You want to see Jackai in 2 minutes? Let me show you Jackai in 2 minutes. Okay, just give me 1 second. Okay, let's take GenAI. GenAI. Okay. Okay. And let's take Qwen. Qwen, QMH, streaming agent. QMH. Okay. Let's take Qwen is a VLM, visual language model. So. No. Here I speak with him, but I don't want to speak with him. So because we have some project, we can make a dialogue with LabVIEW. So I will not take this example. I will take a normal agent. Okay, this one. Okay, this one. But yes, we can speak with LabVIEW. It's possible. Okay. So, but the problem is, okay, I need to, I change my system of license. So give me 1 second because I need to activate my license. But normally here, you can directly upload models, upload any images, and you can directly have the information here of what you see. You can prompt it. So as is a live demo and it's not possible for me to activate the license, I see it 2 minutes before the beginning of the presentation, but it works. So what I invite you can directly download on our website our system, and use directly Qwen 2.5, and you will run it and it will work. So there is no problem. It's just because my license is not up to date and I have to manipulate it now, and it's not the time to do it. So now you kill me. Is there any other question? Free. It's free for a student, and you have 30 days to test it, and after that it's not free for companies. But we can discuss about the price. Don't be timid. What I can let me show you another thing. It's a video. It's a YouTube video, but on our YouTube channel, we already have. Let me show you. In our YouTube channel, we already have. We share a lot of. Okay, let me show you. In our YouTube channel, we share a lot. So you can go directly on the Graphic YouTube channel. And in our YouTube channel, we share what we do. In every 3 or 4 days, we do some video. So video I can show you is Qwen. Okay, without. Okay, so this is a demo I would like to do, but my problem is my license was not working. So that means my license system is very good. So you can prompt it, for example, easily, or normally it's what I want to do. So the speed normally is the normal speed, and it works very fast. So Qwen 2.5, and now we have Qwen 3. It's a Chinese model, is working very well on local. What are the LabVIEW version compatible with the tool VI? For now, we natively develop LabVIEW 2020, but on all the version after 2020. So 20, 24, 25. It's because historically we had license, perpetual license on 2020. But in the future, we'll take a 25 or 26 perpetual license to continue like this. Okay. Is there another question? So that's why what you see here is LabVIEW 2020. It's because we use it voluntary, and we make it some test. If you use, I give you a trick. If you use LabVIEW 2020, you always see the beta version. For example, accelerator, the generalization, is already available on 2020, but not available on 2025. It's just because we make some tests, we work on it, we do some work on it. So as no one is working on 2020, we are good to work on development on 2020. Other question? Okay, so I think my time is finished. Thank you everyone, and thank you the GLA organization for this opportunity to show the potential of SOTA. Hoping that you will test it, so do not hesitate, people, to test my system directly. You can download it directly on the Graphic website. So I give you in the chat directly the link. So graphic.io. And also follow us on LinkedIn. We are really I can also share the LinkedIn because we are very active on LinkedIn and also on YouTube. And you will be able to see what we do. Let me take. Okay. Let me give. I will take directly the link. Okay, so Graphic, LinkedIn Graphic. So follow us, and also follow us on YouTube channel. We show you a lot of things, and for now our stage of development is we finish the majority of our toolkits, and also the future for us will be generalization of graph, and also robotics. So we will go to robotics. So that's what we want to do with Graphic. So thank you everyone for. If we run into issue, is there a support channel on Discord or any? For now, there is no Discord, but we are also we answers by mail, so you can also. Sorry, I will give you directly my contact. It's in my presentation. It's not this one. Up. Thank you, Norm, for the remember. Up. Okay. So you can contact us directly here. Okay, sorry. Okay. You can contact us directly here. Sorry. Voilà. You can contact us directly here, so do not hesitate. We answer the questions. For now, we don't have Discord. Maybe in the future we will do it. We have a forum on the Graphic website. If you have any issue, you can also post your issue on the forum. And also we have a GitHub when we share. On the AIBAL, the latest generation of toolkits will be soon be open source, and we will share it on GitHub, as it's for we think it's good for academic. So thank you everyone for this following presentation. Do not hesitate if you have any question or if you want something, or if you want more information, and we'll be happy to work with the NI community. And again, thank you GLA organization. Thank you.